Hey everyone, welcome to this new series where we'll build a complete planet defense game using Phaser 4 in modern JavaScript. In this game, you control a ship that orbits around the Earth. Your mission? Defend the planet by shooting down waves of incoming asteroids before they crash into it. Along the way, we'll cover core Phaser concepts like sprite movement, collisions, groups, input handling, and even difficulty scaling. You'll also learn how to create effects like explosions, track a score, and build simple UI scenes like a title screen and game over screen. This course assumes you have some basic JavaScript knowledge. If you used Phaser before, even just a little, that's great. But don't worry if you haven't. I'll walk you through the key concepts step by step. To follow along, you will need a code editor and a local web server. For this series, I recommend using the free app, Phaser Launcher, which is both a code editor and has your local web server that we can use for testing your game locally. By the end of this series, you'll have a complete arcade-style game that's fun to play and fully customizable. You can swap out graphics, tweak mechanics, or even extend the game with power-ups, upgrades, or high-score saving. So if you're ready to build something awesome while learning Phaser 4, let's get started. We'll get everything set up so you can start building the planet defense game alongside me. First, let's download our starter files. For this series, I've created a basic project template that comes with a folder structure that works great for Phaser, has all the assets we'll need for our project, and a tiny bit of boilerplate for our Phaser game configuration and our initial scenes we'll be using. You can find a link to the project template in the description down below. To follow along, please download that zip folder now, and when you extract it, you should see the following folder contents. Our assets folder has all the audio and images we'll be using for our game, as well as the Phaser library version we'll be using, so Phaser 4. Our source folder has all of our JavaScript code and our basic boilerplate for our project template, and then we have a few additional files for our project. Next, to follow along with the series, you'll need a code editor and a local web server. For this series, I'll be using Phaser Launcher, which is a free app for creating Phaser games quickly and simply. Phaser Launcher is a code editor and includes a local web server that you don't have to configure. However, if you have your own preferred IDE and local web server, you're welcome to follow along using those tools. So now we have our project template. We need to open this in Phaser Launcher. So under the Projects tab, I'm going to go to Import. I'm going to find our Phaser 4 Planet Defense Project Starter template. I'm going to open that folder, and now our project will be available to us in Phaser Launcher. Let's open our project now. So now we've imported our project. Let's run our game on our local web server. Let's click our Play Game button at the top of Phaser Launcher. This should launch our game, and we should see a black canvas element with this space background. In our console, we should see two log lines tied to our two Phaser scenes. So now we've verified our project's working, let's take a quick look at the code we're starting with. Our index.html is our web page for our game. This has some basic styling and references a background image from our assets to create that space background that we saw. Besides this, we import our Phaser library, and then we reference the main entry point for our web application, which will be our source main.js file. Under our source folder, if we open up main.js, here is where we're creating our Phaser game configuration. We're creating our Phaser game instance based on that configuration, and then we're adding in our two basic scenes and starting our preload scene once our game is ready. For our game, we've enabled arcade physics by default, and we set our gravity to be 0. Besides this, we set some of our default scaling options, so our canvas element will take up as much room as possible with respect to our aspect ratio we specify with our width and height. Next, if we go into our scenes folder, let's open up our preload scene. This is just a basic Phaser scene instance, and all we're doing is in our create method, we're logging out our message that our preload scene was called. We then immediately transition to our game scene, and we do the similar thing where we log out our message. Finally, under our comment folder, we have our assets.js and our scenekeys.js files. Both these files have objects that have key value pairs that we'll be using throughout our code. Currently, our scene keys object has all of the keys that we'll be using for our various Phaser scenes. As an example, if we open up our game scene, we'll see in our constructor for our super call, for our key name, we're referencing our scene keys object with our game scene property. This allows us to reuse those same strings across multiple files in our project, such as in our preload scene, we will reference our game scene here. For our assets.js file, this has all of the strings we'll be using for our asset keys once we load in our assets for our game, and then we have some configuration settings for our various assets we need to load in, such as our Spritesheets that has our information such as our frame width and height, our path to our asset, and then information regarding our animations. Then in our assets.js file, first we have our assets keys, and this has all of the keys we'll be using once we load in our assets in our next video. Besides that, we have a few different objects tied to our various asset types that has metadata tied to our asset key we want to use, our path to our file, as well as related metadata for that file type. As an example for our Spritesheets, we have metadata tied to our Spritesheets width and height for each of our frames. And we'll cover this more in our next video. Finally, at the root of our project, we have this project_task.todo file. This file has a checklist of all the various steps we'll need to complete in order to create our game. We're going to bring our game to life by adding our Earth sprite at the center of our screen, and then placing our player's turret in orbit around it. Let's start by loading in the assets for our project. Under our source folder, let's go into Scenes and open up our preload scene. In this scene here, this is where we'll load all of our game assets, and then that way they're available for all the other scenes we'll create. So now let's remove our console log from our create method. So now for our preload scene, we want to make sure we load all of our assets before we transition to our game scene. To do this, let's use our preload method on our scene, and any assets we load in here, Phaser will make sure they're ready and available for us before our create method gets invoked. So now to load in our game assets, we need to load in all the assets under our audio and images under our assets folder. Alright, so I'm going to open up our media browser. To take a look at our assets, we'll need to load for our project. So under our assets folder, under audio, and then our instruments folder, we have 4 audio files that we'll need to load. These audio files will include things like our background music and our sound effects we play, like when we shoot our bullets or when we destroy one of the asteroids in our game. Under our images folder, we have a few different folders, and so this is going to include things like the background for our game, our player's ship that will orbit our planet, as well as the asteroids that will be coming at our planet. We'll have a heart sprite sheet that will be used for displaying our planet's health, and then we have the background that we're using in our index.html file. So now for each of these assets, we need to load these in our preload method. Typically to do this, we would do things like this.load.image, and then we can provide our cache key that we want to associate with this image data, and then the path to the image file we want to load. So instead of manually doing this for each of our files we need to load in, we're going to rely on our assets.js file. Inside this file, we have a few arrays that have objects that contain the metadata for each of our files we want to load in our project. So as an example, we have this image assets array here that references our 2 images for our ship and our asteroid that we need to load in. This provides us the asset key we want to use throughout our project, as well as the path to our file. And so to reuse this image assets array here, we'll need to import that into our preload scene. So at the top of our file, let's do our image_assets. We're going to do from, we need to do ... we'll go up a folder, we'll go in our common folder. Now we want to do our assets.js file. So now down our preload method, we can reference our image assets, and then we can use our for each method to iterate through our array. And now for each of our asset objects, we'll want to run this line of code here. So let's paste it. And now we want to reference our asset object. So we'll do our asset, and now we want to do our asset key. Now let's do our asset, and we'll do our path. So now if we want to verify if our code is working, let's jump over to our game scene. In our create method, let's remove our console log. Let's create an image game object for our player ship. So we're going to do this, we'll do add, and we'll do image to create our image game object. And now for our positioning, let's do 0, 0. And now for our texture, we want to reference our asset keys. So we'll need to come to the top of our file, we want to import that in. So we're going to import our asset keys from, we want to go up a folder, we'll go into common, and now we want to do our assets.js file. Now back in our method, let's do our asset keys, and we want to reference our ship. Now if we save, let's launch our game. Now when our game starts, up on the top left-hand corner, we should see part of our player's ship. So to fix this, let's update our x and y value. And so we're going to go ahead and do 200 for our x, and let's do 200 for our y. Let's launch our game again, and now we should see our player's ship on our canvas element. Now that we've verified our logic for loading in our images is working properly, let's jump back over to our preload scene, and now we want to load in the rest of our game assets. So now in our assets.js file, we'll want to load in our Spritesheet assets and our audio assets. So I'm going to copy our variable names, jump over to our preload scene, and I'm going to update our import statement to include those. So we'll have our audio assets, our image assets, and now we want to do our Spritesheet assets. So I'm going to copy this block of code here. I'm going to paste it twice. Now let's do our audio assets. Now for our audio assets, we want to do this.load.audio and then provide our asset key and our path to our audio files. Now for our sprite sheets, we'll loop through our array. Instead of doing an image, we want to load in a sprite sheet. For our sprite sheet, we'll do our asset key, our path, and now we want to do our configuration for our sprite sheet. So we'll have our frame width. For this, we're going to do our asset, and we'll do our frame width property. And now we'll do our frame height, and let's do our asset and our frame height property. Finally, for our game, we'll want to create any animations that we'll need for our sprite sheets that we loaded in our game. So if we go up to our media browser, I'm going to go into our images folder under Foozle, and a good example here is our asteroid explosion PNG here. So this file, this is a sprite sheet, and for our sprite sheet, we'll want to create an animation for once one of our asteroids explodes in our game. Our animation will need to know about all of the frames here and our rates that we want to play our animation in our game. So in our assets.js file, under our sprite sheets array, we'll see we already have properties here for our frame width and our repeat property. And so to create an animation for each of our sprite sheets, we need to come back to our preload scene. First, we'll need to wait until our sprite sheet texture has been loaded. And then once it's available, we can tell Phaser to create our animations from that sprite sheet. To do that, let's come down to our create method. I'm going to copy our block of code here where we loop through our sprite sheets array. So as we're iterating through our sprite sheets array, let's get rid of this code. Now to create our animation configurations, we'll do this to reference our Phaser scene. We're going to do anims to reference our animations manager. And now we want to do the create method to create our animation. So now for our animation, we need to give each animation we create a unique key. For this, we'll be using the same key as our asset key. So we'll do asset, and let's do our asset key. Next, we'll need to tell Phaser which frames of our sprite sheet should be used for this animation. Currently, all the sprite sheets we're using in our game, they'll be using every single frame for the animation we create here. So now to tell Phaser which frames we want to use, we need to use a utility method. We're going to do this. We're going to do anims to reference our animation manager. And now we're going to do generate frame numbers. And so inside this method, we'll want to pass in our asset and then our asset key. So what this method does is, based on the texture that we provide to this method, Phaser will use that texture information to dynamically create our frame configuration we need. If we go under our images folder, I'm going to open up our asteroid again. So as an example for our asteroid, when we provide this texture to that method, Phaser is going to take each of these frames and then create the frame information we need based on the texture information we provided up here. Finally, if we tell Phaser about our frames, we can specify our frame rate, so how fast we want this animation to play. So we're going to reference our asset, and let's do our frame rate property. And now if we want this animation to repeat or not. So we'll do repeat, and we'll reference our asset, and then our repeat. So now that we've created our animations that we need for our game, that wraps up all of our assets. So now let's jump over to our game scene, and we're going to start creating some game objects to add to our scene. To start with, we'll add in our backgrounds that we'll be using for our canvas element. And so for our background for our game, this is going to consist of multiple images. So if we open up our media browser, let's go under images, we'll go under Foozle, and we'll have 3 background images here we're going to want to add to our game. Each of these background images are a sprite sheet that'll create a really nice animation once we play that animation for our game. For our background, first we'll want to put in our background 1 game object. We'll layer our background 2 on top of it, and then finally we'll add in our background 3. And so for our background game objects, we'll want this to be behind everything else in our scene. So we're going to create those game objects before our players ship. Let's start with our first background. So we're going to do this.add. And since we want to be able to play our animations, we're going to create a sprite game object. So now for our sprite game object, for our X and Y value, we'll do 0. And now we need to do our asset key. We'll have our asset keys, and we want to do our background 1. Since this is a sprite sheet, we're going to use the first frame of our sprite sheet. So if we save and come over to our browser, we'll see our background game object has been added to our scene. Currently, our origin is in the middle of our game object, so let's update that to be in our top left-hand corner. So we're going to do set origin, and we'll do 0. If we save, let's come back to our game, and we'll see right away our background's been moved, but it's not taking up our full width and height. To do this, we'll need to scale up our game object a little bit. So if we come back to our code, let's do set scale, and now for our X property, we'll do 1. For our Y property, we'll do 1.25. Let's test one more time, and now we'll see our background is taking up our full width and height of our canvas element. Finally, for our sprite game object, we'll want to play our animation, so let's do play, and now let's reference our asset keys, and we'll want to do our background 1 asset key. Alright, so we save and come back to our game. Our background game object should now be playing our animation, but for our first layer, it's very subtle, so you might not notice it moving very much. Currently, our background is very bright for our game, and so with this being in space, we want this to be a little bit darker. To fix that, we're going to update the alpha on our game object, and so we're going to set this to be 0.4, and that way our game object should be more transparent with our black background, and now we have this nice color here. So now that we have our first background game object, we now need to create 2 game objects for other 2 background layers. To do that, let's copy our line of code here for where we create our first background. We're going to paste it twice. Let's update our asset key we're referencing. So we'll have background 2, and then we'll have background 3. We'll want to update our animation that we're playing. All right, so now if we save and come back to our game, we should see this very nice background that we can use for our game. So now before we create our planet game object, one thing we're going to do is we're going to refactor our code for how we're creating our game objects for our background. Currently, our code is very repetitive since we're doing the same thing for each of these game objects. Instead of doing this for our code, we're going to create a simple for loop, and we'll use that to create our game objects. So let's do for. We're going to do let I equal 1. If I is less than 4, let's increment I. Let's copy one of our lines of code. So now inside our for loop, we'll create our game object. I'm just going to format our code a little bit. And now in our for loop, all we need to do is update our asset key that's being used when we create our game object and to play our animation. To do that, let's do asset keys. We'll do our bracket. Let's do our backtick. And now instead of doing background 1, we're going to do background I. Let's copy this and we'll do the same thing for when we go to play our animation. So now let's remove our 3 lines of code above our for loop. Let's save. If we come back to our game, we should still see our background. Nice. So now that we have our background game objects, let's create our planet. For our planet, we'll want to create a sprite game object. So let's do this.add. Let's do a sprite. Now for our X and Y value, we want to position our planet in the center of our game. To do that, we can use the scale manager on our scene, which will allow us to grab our properties for our width and height for our game. So for our X value, let's do this to reference our scene. We're going to do scale to reference our scale manager. And now let's grab our width property. We're going to divide it by 2, so that way we'll be in the center of our screen. Now we'll do the same thing for our height. So we'll do this.scale.height. Let's divide that by 2. And now for our asset key, we're going to do asset keys, and we'll do our planet. And since this is a sprite sheet, let's do 0 for our frame. And now we want to play our animation. So we'll do .play. Let's do our asset keys, and let's do our planet. We save, and we come back to our game. We now see our planet game object has been added to the center of our screen. So now for both our player and our planet game objects, we'll want to store a reference to these 2 game objects on our class. That way later on, we'll be able to reference them. So the top of our class, let's add 2 private properties. First, we'll create a property for our planet, and now let's create a property for our player. So now we have our 2 properties in our class. Let's come down to our create method. Let's do this. We'll reference our planet property. We'll say equal to this.add sprite for our planet. Now let's do this, and we'll do our player. We'll say equal to this.add image for our ship. And that's it. We've now loaded in all the assets that we'll need for our project. We've set up our animations that we'll need, and then we create our background, our player, and our planet game objects. For our background and our planet game objects, we use sprite game objects. That way we'll be able to play the animations that we created. Now that we have our player and our planet game objects, we need to add in our code to have our player ship orbit around our planet. To do this, we're going to use a little bit of trigonometry, specifically our math sine and math cosine functions, to calculate our x and y position of our player's ship. We'll then need to update our player's ship rotation to have it face in the correct direction. So how this will work is we want our player's ship to orbit around our planet here. Our planet is in the center of our screen, and we just want our player to move in a circle around our planet. A good way to think about this is for our player's ship, if we imagine we have a string attached from the center of our planet to our player, and we just have that string move around the outside of our planet, we'll create this circle here. And so this is the path we want our player's ship to follow. And so to calculate this, we first need to figure out our radius, so how far we want our ship to be away from our planet. And then we'll need to calculate an angle to figure out our x and y position of where our ship should be on this circle. And so how this will work is to calculate our x and y values, we can use our sine and cosine functions. These functions, when we have a triangle, they can be used to find the lengths of our two sides of our triangle. As long as we know what that angle is, and we know what our hypotenuse of our triangle is, we can calculate those two sides. How this works with our planet is our origin, 0, 0. This will be the center of our screen, or where our planet is currently located. For our hypotenuse, this is really just our player's radius away from our planet on this circle. And then for any given angle that we specify, we can figure out our x and y position for where our player would be at on this circle. And so don't worry if this sounds too complicated. This is actually really easy to do with our code and some of our built-in math functions. So if we jump back over to our code, first we need to create a property to keep track of that angle that we're referring to here in our diagram. So on our class, let's make a new private property. We're going to call this player angle. Now down in our create method, after we create our player game object, let's set our angle to be 0. So we'll do our player angle is equal to 0. And now we're going to create a method to calculate our player's position. We're going to do this. We'll make a private property. We're going to call this update player position. I'm going to copy our method name. Let's add that private method to our class. And since we're calculating our player's position here, I'm going to update our x and y values here to be 0 from when we first create our game object. So now in our method, we want to calculate our x and y values. So we do const x is going to be equal to this, our scale manager. We want to grab our width and divide it by 2. We're going to add this, our planet, our display height. We're going to divide that by 2. And now we're going to multiply it by our math and then our cosine function. And then we need to pass in our player's angle. So now for our y value, this is very similar. So I'm going to copy this line of code. Let's paste it. Do our const y. It's going to be equal to our scale manager. We want to grab our height. And then we'll do our planet's display height divided by 2. We're going to multiply it by our math.sine. Now that we have our x and y properties, let's do this. We're going to do our player. We'll do set position. And we'll pass in our x and y properties. Alright, so now if we save and we come back to our game, we should see right away our player's ship game object, our position has been updated to be placed in orbit around our planet. So now if we want to see if our code's working properly, we should be able to update our player's angle, and it should move our ship around our planet. So I'm going to set this to be 10. Now for our angle, our ship is over here. So for our angle, I'm going to set this to be 1. We'll see now our ship has moved a little bit around our planet. Let's do 2. Our ship has moved a little bit more. 3. And we'll see as we keep updating our angle, our player's ship keeps updating to orbit around our planet. Alright, so if we come back to our code, what we're doing in our update player position method is first, we're finding the center of our screen, so where our planet is currently located, by using our scale manager. We're using our scale manager width and height properties and dividing it by 2 to get our x and y coordinate. So for our diagram, this is how we figure out where our origin is of our one point on our triangle. Next, we're calculating our player's radius by taking the display height on our planet and dividing it by 2. So for our image game objects, when Phaser loads these are going to be a square image in our game. Since it's just a square, if we divide it by 2, we can figure out how far away our player's ship should be from our planet. And so with that radius, that's what we're using here on our triangle for our hypotenuse. Finally, we're taking that value and we're multiplying it by either our math.sine or cosine to figure out our x and y value. And so for our math, sine, and cosine functions, we need to provide an angle to figure out where our ship would be on our circle here. So as an example, when our angle is set to 0 degrees, our player's ship should be located over here. And as we increase our angle, our player's ship should move around our orbit here. So a few things to know as we're talking about our degrees here and calculate our x and y position, and when we run our code and update our position in our game, is when we're calculating our x and y position, when we do our degrees, we're starting at 0 degrees here, and we're moving this way around our circle. So instead of moving counterclockwise to calculate our angles, really for our Phaser game, 90 degrees is down here, 180 is over here, and 270 is up here. The second thing is when we use our math.sine and math.cosine functions, these functions expect us to pass our argument as a radian instead of degrees. And so this is important to note because when we passed in our values of 0, 1, 2, 3, 4, and 5, we saw our ship moved very far around our circle, where if it was degrees, we'd expect our ship not to move very far. And so if we do a quick calculation on our radians to degrees, we'll see when we pass in 0, this is 0 degrees. When we pass in 1 radian, that's about 58 degrees. 2 is about 115. 3 is about 172. And then 4 is about 229. So when we pass in those values, that resulted in our ship moving quite far around our orbit because our radians were converted to that number of degrees. Since we're really working in radians, let's update our property to reflect that. So we'll do player angle in radians. Let's copy that. We'll come down here. We'll update our references to that property. So now that we have our logic for updating our player's ship's X and Y value, now we just need to update the rotation of our ship's game object so it faces outwards away from our planet. To figure that out, if we come down to our update player position method, after we update our X and Y value, let's reference our player game object. We're going to reference our rotation property. We're going to set it equal to this, our player angle. We're going to add our math.pi. We'll divide it by 2. So now if we come back to our game, we'll see our ship has now been rotated to face away from our planet. Likewise, if we update our angle, our player ship's location should be updated and it should be facing away from our planet. Now that we have our player's ship orbiting around our planet, we'll want our player to be able to control it. So let's hook up some input. We'll listen for our left and right arrow key presses, and when one of these keys are pressed, we're going to update our player angle and radians property. As this property changes, we'll want to call our update player position method to have our player's ship's location be updated. So to enable input for our game, let's come to the top of our class, let's add a new property, and we're going to call this cursor keys. Now if we come to our create method, after we create our player's ship, let's do this, we'll do create cursor keys, and we're going to set it equal to this. We're going to do input to reference our input manager. Let's do keyboard to reference our keyboard plugin. And now we want to call create cursor keys. And so what this method does is this is a shortcut for us to create and return an object that has hotkeys for our arrow keys we want to check for input on. So now that we have these hotkeys, we need to check to see if one of our keys is being pressed, and if so, we'll update our player angle and radians property. To do this check, we want to do this in our update method. Our update method is going to be called multiple times per second or once for every tick of our game loop automatically by phaser. And so this method is really great for when we want to check for our player's input and then handle it accordingly. So now to check to see if one of our keys is being pressed, we'll do if. We're going to reference our cursor keys object, and now we're going to check for our left key. And if our left key is down, then we want to update our player angle and radians property. So I'm going to copy this here, we'll paste it, but instead of assigning a value, we're going to decrement 0.06 from our property. Now we want to do the same thing if our right key is pressed, so I'm going to copy this, and we're going to do else if our right key is down, then we want to increase our radians. Finally, after we update our player angle and radians property, now we want to call our method for updating our player's position. So we're going to copy this line of code, we'll paste it, let's save, come back to our game. So now if we press our left key, we'll see our player's ship starts orbiting around our planet counterclockwise. If we press our right key, our ship will orbit around our planet in the other direction. Nice. And that's it. We now have our player's ship orbiting around our planet, fully controlled by our keyboard.
We're going to give our orbiting ship the ability to shoot, and it's going to fire outward from the Earth to defend the planet. For our bullet, we'll be creating a physics sprite game object. We're going with a sprite since we have an animation we'll want to play for our bullet once we fire it. To manage our bullets, we'll be using a phaser physics arcade group. That way we can spawn multiple bullets, reuse them efficiently, and take advantage of collision detection later. If you're not familiar with phaser groups, a group is a way for you to create, manipulate, and recycle similar types of game objects. A group is almost just like an array with a bunch of helper methods for working with that group. And at a high level, I like to think of groups as an object pool. So to create our phaser group and our game scene, first let's add a property to our class. We'll call this bullet group.
Now down our create method, after we create our player, let's do this. We'll do our bullet group will be equal to this.physics.add.group. And now for our group, we'll pass an empty array for our initial children. So now that we have our group, we need to have a way to actually fire our bullets. So to add our firing behavior, we're going to check for when the player presses our spacebar or taps on our screen, we'll create a bullet, then we'll position it at our player's location and give it a velocity based on the angle of our player. And so for this, we'll use some of our built-in utility functions in Phaser. So to check for our player input, let's come down to our update method. After we update our player's position, we'll want to check to see if our space key was just pressed. So let's do if, we'll do our Phaser, let's do input, keyboard, just down. And now we want to do this, we want to reference our cursor keys. And from our cursor keys object, we want to grab our space key. What this method will do is going to check to see if our key was just pressed down and that's not being held down. Now that we have our check for when our space key is pressed, we can fire our bullet. For firing our bullet, we'll make a new method on our class. So let's do this, and we'll do fire bullet. Let's add that new private method to our class. So we'll do fire bullet. So now in our fire bullet method, first we'll want to get our X and Y position of where our player is at, and then calculate our velocity based on the angle of our player. So for our X and Y values, we can grab those from this, our player game object, and then our X property. We'll do the same thing for Y. Now for our velocity, we're going to reference our physics system. And now we're going to use a method called velocity from rotation. What this does is going to take our rotation in radians from our player and the speed we want our bullet to move, and it's going to give us back our velocity as a vector. So for our angle, we're going to reference our player angle property. And now for our speed, let's do 400 for our bullet. Now we need to create our bullet game object. For this, we'll be relying on our Phaser group, so that way we can reuse our game objects. So let's do const, we'll do bullet, is going to be equal to this, our bullet group. We're going to call the getFirstDead method. So what this method does is it allows us to reuse game objects that are no longer active in our game that are part of our existing group. If a game object is not found, we can create a new one on the fly. To do this, we need to pass in our right arguments. For our first argument, we want to pass in true, indicating that we want to create a game object if one's not found. Next, we can provide our X and Y values of where we want to place our new game object or where we want to place our existing game object that's not active. If a game object is not found, then we need to tell Phaser what texture we want to apply. For our texture, we're going to use our asset keys. We want to use our bullet asset. Since this is a sprite sheet, we can provide our frame, so we'll do frame 0. And then finally, we want our game object to be visible as soon as we shoot our bullet, so we'll pass in true. So now at this point, we should have our bullet. And so now I'm just going to do a console log. We're going to log out our bullet game object. So I'm going to save, I'm going to come back to our game. If we press our space key, we'll see we start spawning our bullet game objects. So now that we see our logic is working, we just need to update our velocity and our rotation on our bullet game objects so we can move them away from our ship. Let's remove our console log. We'll reference our bullet game object. We're going to call the setVelocity method. Now in this method, we need to provide our velocity for our X and Y properties, as we'll use our velocity object. We'll do velocity X and then velocity Y. Now we need to update our bullet's rotation. So we'll do our bullet, we'll do set rotation. We'll just use our rotation from our player. And finally, after we fire one of our bullets, I'm going to add a console log statement to keep track of how many bullets we've actually fired. We'll do fire bullet. We'll say number of bullet game objects in the group. And to get this value, we can reference our bullet group. We're going to call the getChildren method. And this method will return an array of our game objects that are part of our group. And since it's an array, we'll just log out our length. So if we come back to our game, if we press our space key and we fire one of our bullets, we'll see it fires outward from our ship. Nice. To make sure our bullets don't spawn too fast, let's add a firing cooldown. We'll create a timer that tracks when our last bullet was fired and only allow a new bullet if enough time has passed. This will prevent the player from spamming our space key to keep firing bullets. To add in this logic, first, we need to add a property to keep track of when our last bullet was fired. So at the top of our class, let's do last bullet fire time. And down in our create method, we'll initialize that value to 0. So after we create our bullet group, we'll do this. Our last bullet fire time will say equal to 0. So now for our timer, to keep track of how much time has passed in our game, we can rely on our update method. And so when Phaser calls our update method in our scene, we receive 2 arguments. Our first argument represents the current time of our game. And so based on this value, we can set our last bullet fire time to that time when our player presses our space key. So let's do this. We'll do our last bullet fire time will be equal to our time. So now that we're keeping track of the last time we fire one of our bullets, in our if statement, we can now check to see if the current timestamp is greater than our last bullet fire time plus some value. And for this, we'll do 200 milliseconds. So now if we save and we come back to our game, if we keep pressing our space key really fast, we'll see now we only spawn our bullets within that interval. Finally, we also want to make sure our bullets get cleaned up when they go off our screen. Currently, as we're firing our bullets, our number of game objects in our group keeps growing in size. If we don't remove them, we'll end up with thousands of invisible bullets, slowing things down in our game. In order to reuse our game objects for our object pool, we'll need to check if our bullet's position is outside the bounds of our game, then make our game object inactive once it is. To add in this logic, we'll do this in our update method. So after we do our check to see if we need to fire a bullet, we'll want to clean up our bullets. To do that, we need to get a reference to all of our game objects in our group. So we'll do our bullet group. Let's do get children. Now for our array, we'll want to iterate through it. So now for each of our bullets in our group, first we want to see if our bullet's currently active. And so we'll do bullet.active. So if our bullet is currently active, and now to see if our bullet is outside the bounds of our game, first we'll check our X position. So if our bullet.X is less than 0, so it's moved off the left-hand side of our screen, or if our bullet.X, if it's greater than our scale.width, that means it moved outside the right-hand side of our screen, or if our bullet.Y value is less than 0, it moved outside the top. And now for the bottom, we'll do our bullet.Y. If it's greater than our scale.height, then we want to make our bullet not active, and so we're going to call set active. We'll pass in false, and then we want to make our bullet not visible. And so we'll pass in false. Now if we save and try firing some of our bullets, we'll see once our 3 bullets move off our screen, we start reusing our game objects. However, we have an issue now where our bullet is no longer visible once we start firing it, and now if we press our space key, our bullet's path gets interrupted and we respawn our game object. What's happening is in our logic here, we're setting our game object to not be active and we're making it not visible. Down in our logic for once we fire our bullet, when we grab that game object, we need to reset those properties. So after we get our bullet game object, we want to call set active. We're going to pass this to be true. And now we want to make our game object visible. So we'll pass in true here. So now if we save and we start firing our bullets, we'll see now we're reusing our bullets properly. Nice. Finally, for our bullet game objects that we're spawning, they're a little bit small, so we're just going to increase our scale on our game objects. So we're going to call our set scale method, and now we're going to pass in 1.5. So now if we save and spawn one of our game objects, we'll see it's a little bit larger. And then finally, for our bullet game objects, we have an animation we want to play. We're going to use our play method, and we'll reference our asset keys and then our bullet asset to play our animation. So now if we come back to our game, we'll see now our bullet game object is playing our animation when our bullet is fired. Finally, one last thing we'll do for our bullets is we always want to make sure our physics body is enabled for our bullet. To do this, we just need to call our enable body method, and this will make sure our physics body gets reset for our game object. So currently, we're not disabling our physics body on our bullet, but we'll make use of this later once we add in our asteroids. And that's it. Our ship now fires bullets that fire outward. Now that our ship can fire bullets, it's time to give the player something to shoot at. We'll add enemies to our game. They'll spawn from the edges of our screen and move toward the Earth at the center. First, we'll start by creating an enemy sprite. and a group to manage all of the enemies in our game. Just like with bullets, we'll use our Phaser Physics Arcade group so we can easily spawn, manage, and destroy your enemy sprites. Now to create our group, let's come down to our create method after we create our bullet group. And now for our method, we'll pass in an empty array for our initial game objects. So now that we have our group for our enemy game objects, we'll want to create a method for spawning an enemy in our game, just like what we did with our fire bullet. So at the bottom of our class, let's make a new private method and we'll call it spawn enemy. So now for spawning our enemy game object, we'll want to rely on our physics group. So let's do const enemy will be equal to this, our enemy group, and we'll use our getFirstDead method. We'll want to pass in true so we create our game object if one doesn't exist. And now we need to provide our X and Y position. So for the time being, we'll pass in X and Y. And now for our texture, we'll do our asset keys, and let's do our asteroid. This is a sprite sheet. We'll pass in 0 for our frame, and we'll do true so our game object is visible. Now we want to define our X and Y values. For the time being, we're just going to set these equal to 0. So we'll do let X equal 0, let Y equal 0. And now that we have our game object, we'll want to make sure it becomes active and visible, just like what we did with our bullet. So we'll have our enemy. First we'll do set active, let's pass in true. And we'll do set visible, we'll pass in true. We'll want to enable our physics body. And like what we did with our bullets, let's log out how many children exist in our group. So we're going to copy this line of code. We'll paste it. Let's update our log statement. And so we'll do spawn enemy, and we'll do number of enemy, game objects and group, and we'll want to reference our enemy group. Now that we have our basic logic in place for spawning our enemies, we need some type of trigger in our game to actually spawn our enemies. For this, we'll use a repeating timer that'll spawn our enemies at regular intervals. So to create this timer, we're going to use some of our built-in utility methods in Phaser. We come up to our create method after we create our enemy group. Let's do this, we'll do time, and let's do add event. So what this method does is it allows us to create a timer event for our game. Our timer event allows us to tell Phaser that we want to run a set of code at a given time. For this, we can run our code right away. We could introduce a delay and say we want to wait so long before we run our code. And we can even have this loop where we'd wait a second before we do something, wait another second before we repeat that. And so to use this, we need to provide a configuration object to tell Phaser what we want to do in this event. For our first property, we'll do our delay. And this is just going to tell Phaser we want to wait this number of milliseconds before we invoke our callback for this timer event. So now we need to provide our callback that we want to do. And so this will be our spawn enemy method that we created. Next, we'll provide our callback scope, and we'll pass in this, so we have this scene's instance for our scope. And finally, for our event, we want this to loop. So let's pass in true. Alright, so now if we save and come back to our game, we should see after our initial delay, we trigger our callback and we start spawning our asteroids. We'll see in our console log, we continually spawn our asteroids after that 1250 milliseconds has passed. So now that we have our logic working for spawning our asteroids, we need to update our spawn locations. Currently, all of our asteroids are spawning at location 00, and we want to give each one a unique location. For this, we'll choose a random spot around the edge of our screen. To make this change, let's come down to our spawn enemy method, and now we'll need to choose which edge of our screen we want to spawn our asteroid from. So either our top, our bottom, our left, or our right. For that, we just need to generate a random number. So let's do const, we'll do edge, we're going to set that equal to our Phaser, we'll do math, and we'll do between. And so this method will return a random value in the range we specify. So we'll do 0 for our min, and we'll do 3 for our max. So now we'll have our 4 possibilities for our edges. And so now based on that edge value, we can update our X and Y property. And so now if our edge is equal to 0, that's going to be our left edge of our screen. So for our X value, we'll want this to be 0. For our Y value, we'll want this to be a random position at the top of our screen towards the bottom of our screen. So to get that value, let's copy this line of code here, where we grab a random number. Now for our values, our minimum value will be 0. And now we want to do this.scale to reference our scale manager, and we'll do our height to grab the size of our game. Now we just need to repeat this for our other edges. So I'm going to copy this block of code, and we'll do else if. So now if our edge is equal to 1, now we want this to be our right-hand side. So we're going to set our X value equal to our scale width. For our Y value, we want to do the same thing where we choose a random Y position. Let's copy that block of code. Now if our edge is equal to 2, we'll want this to be our top of our screen. And since it's the top, we'll want our y value to be 0. And now we want to do a random value for our width. So we're going to copy this for our x. And we'll update this to be this.scale.width. Finally, we just have the bottom of our screen. So we'll paste our code. Let's get rid of our else if and just make it an else. And now we just want our y value to be the bottom. So we'll do this.scale.height. Now if we save, let's come back to our game. And now when we spawn our asteroids, they should start spawning at random locations along the edge of our screen. Nice. Now that our asteroids are spawning in random locations, we need to start having them move directly towards our planet. To do that, we're going to use some of the built-in utility methods on our physics system. So after we create our enemy game object, we're going to do this.physics to reference our physics system, and now we're going to use the move_to method. So what this method does is we can take any game object that has an arcade physics body and give Phaser a destination we want that game object to head towards, and internally, Phaser will calculate the velocity we need to apply to that game object and add it for us. And we can also adjust our speed by providing a max amount of time we want to wait before we get to that location. So to use this method, first we need to provide our enemy game object. Next, we need to provide the position we want to target. So this will be the center of our screen. So we'll do this.scale.width. We'll divide it by 2. Now we want to do the same thing for our height, for our y value. And now we can provide an optional speed, which will affect our velocity. So we'll pass in 50. Now if we save our changes, let's come back to our game. Now, after we spawn one of our asteroids, they'll start heading directly towards our planet. Now, let's make sure we clean up our enemies properly. Just like with our bullets, once our asteroid is off our screen, we'll want to disable that game object so we can reuse it. So back in our code, in our update method, we'll want to take a similar approach to what we did with our bullet group with our enemy group. Let's copy that block of code. We'll paste it. So instead of our bullet group, let's do our enemy group. We'll grab our children, and then when we loop through our array, instead of doing our bullet, let's do our enemy. And now for enemies active and our x value, so instead of doing 0, let's add a little bit of a buffer, so we'll do -50. And now for enemy x is greater than our scale width, we'll add that same buffer, so we'll do 50. Now for bullet y is less than -50, or for enemy's y position is greater than our scale.height plus 50. Then we want to make our enemy not active, and we want to make it not visible. So now if we save and come back to our game, eventually we should start seeing our console log messages repeat for the number of enemy game objects that are in our group. Now, let's polish things up a bit. We'll rotate our enemies slightly as they move in and give them a little scale variation so they look more organic and chaotic. We'll also update the size of our physics body on our game object to more accurately reflect the size of our asteroid. To make these changes, let's come down to our spawn enemy method. Once we have our enemy game object, first we'll call setScale. And now for scaling our enemy game object, we'll want this to be a random number. So let's do our Phaser, we'll do our math. And instead of doing between, let's use float between. So what this method does is it allows us to return a floating point number. So now for our scale factor, for our minimum value, let's do 0.75. And now for our max value, let's do 1.25. Now if we save and we come back to our game, we'll notice now when we spawn our asteroids, they're in different sizes. So next, let's fix our arcade physics body. To do that, we need to reference our enemy game object, then our body property, and we want to call setSize to update the size of our physics body. Now for our physics body, we'll want this to be based on our current display width and our height since we just scaled our game object. So do our enemy, let's do our display width. We're going to multiply this by 0.3, and now for our height, we'll do the same thing, but with our display height. We'll also multiply that by 0.3. Now if we save and we come back to our game, so now when we spawn our asteroids, our physics body will be more closely aligned with the size of our asteroid sprite we're showing to our player. Finally, to rotate our game objects, we need to do that in our update method. For this, when we're looping through our child game objects in our enemy group, if we don't disable our game object, then we want to update its rotation. So to update our rotation, we need to reference our enemy game object, and now we want to reference our rotation property, and now we're going to do plus equals, and we'll do 0.02. Now if we save and come back to our game, now as our asteroids move towards our planet, they're now rotating. And so for our rotation, we'll want to make this a little bit more random, and so for each of our asteroids we spawn, we'll want to give it a unique rotation value. To do that, we'll need to store some data on our game object, and when we store our data, we'll need to give it a unique key. So for this, let's come to the top of our file. Let's make a new object. We'll do const. Let's do data keys. For this object, let's do object.freeze. And now for our key, we're going to call this rotation speed, and we'll set our value to the same thing. So now down in our spawn enemy method, after we update our scale, we'll do set data. And so what this method allows us to do is we can store additional data on our game object as key value pairs, and then later on reference this data property on our game object to get those values. So by setting our rotation speed here up in our update method, we'll be able to retrieve that value for this particular game object. So now for our key, we'll want to do our data keys. Let's do our rotation speed. And now we want to generate a random value for that rotation speed. So let's do phaser. We're going to do our math. Let's do our float between. Now let's do negative 0.02, and we'll do a positive 0.02. And then that way each asteroid should be a little bit more unique. So now we'll just need to update our update method. So instead of having our hard-coded rotation value, we'll do plus equals, and we'll do our enemy game object, and now we want to do get data. So now when we call get data, we just need to pass that same key. We'll do our data keys and then our rotation speed. Now if we save and come back to our game, now when our asteroids spawn, each one should have a unique size and a unique rotation value. Nice. Now that we have our logic in place for spawning our enemies, and each enemy game object is a little bit unique, we're going to make things more interesting by adding some difficulty scaling. So currently, when we spawn our asteroids, it's on a set timer, and so our game's very predictable, where every 1.25 seconds, we're going to spawn an asteroid. So instead, over time, we're going to gradually increase how fast our enemies will spawn, and this could be maybe every 10 or 15 seconds, or even be based on our player's score. This will give our game a nice difficulty curve and keeps players on their toes the longer they survive in the game. To make this change, we'll need to refactor some of our code. For our first change, we'll need to update our timer event here so we can store a reference to it. That way we can stop our timer and restart it with new settings. Currently our delay is hard-coded to 1250, and we want this to be a property that we can modify. For a second change, when we set our enemy headed towards our planet, we have a hard-coded value for the speed we want our game object to move. Instead, we'll want this to be a property as well, so we can increase the speed of our asteroids. So to add these properties to our class, let's come to the top of our class. First, we'll add a property for our enemy speed. So we'll do enemy speed. This will be our number. Next, we'll add a property for our spawn delay. And then finally, we want a property to keep track of that timer we created, and so we'll call this spawn timer. So now if we come down to our create method, let's set our initial values. So after we create our enemy group, first, let's set up our spawn delay. So for this, we'll set this to our 1250 value. Next, we'll do our enemy speed. We'll set this equal to 50. And now we'll want to store our reference to our timer event. So we'll do this.spawnTimer will be equal to this.time.addEvent. So now before we make our change for our difficulty, let's update our code to use our new properties. And so we'll do this, our spawn delay for our delay here. And now if we come down to our method where we spawn our enemies, and so in our code where we do this physics.moveTo, instead of doing 50, let's do this, our enemy speed. Alright, so now if we save, if we come back to our game should be working just like it was before. So now we've added our new properties, now we can add in our logic for increasing our difficulty. For this, we're going to create a new timer event where we'll increase our difficulty every 10 seconds in our game. So after our spawn timer, we'll do a new timer event. So we'll do this.time.addEvent. And so now for this timer event, we'll add in our delay. We want to do 10 seconds, and so that's going to be 10,000 milliseconds. Now for our callback, we'll make a new method on our class, and we'll call this increase difficulty. For our callback scope, we'll pass in this. And then finally, for our loop property, we'll set this to be true. Let's copy our new method name. We'll come down to the bottom of our class. We'll paste in our method. So in our increased difficulty method, when this is called, first we'll want to update our spawn delay. We'll want to decrement our existing value so that way our enemies start spawning faster. I'm going to add a console log so we can see what this value is, and we'll say spawn delay decrease to, and then we'll pass in our spawn delay value. So now that we've updated our spawn delay, for this to be applied to our timer, we'll need to destroy our existing one and recreate it. So we'll do this, we'll reference our spawn timer, and let's call the destroy method on our game object. And now we want to recreate our timer event. So we come up to our create method, let's copy this block of code here, we'll paste it, and so now we'll recreate our timer event with our new delay. So this will take care of spawning our enemies faster. Now we want to increase our enemy speed. For that, we'll do this, we'll reference our enemy speed, and we're going to increase it by 10. We'll also log out this value. So I'm going to copy this line of code here, we'll paste it, and so we'll say enemy speed increase to our new value. So now if we save and come back to our game, if we wait long enough, eventually we should see our new log messages for where we're increasing our enemy speed and we're increasing how frequently our asteroids spawn. So the longer our game goes on, we should start seeing our asteroids speed up and we should start seeing more instances of our game object. Finally, for our difficulty scaling, we're going to introduce a few limits. For these limits, we don't want to keep increasing our enemy speed indefinitely. Instead, we want to have a max limit for how fast our enemy can move. We want to do the same thing for how frequently we spawn our enemies, and then that way they're not spawning instantaneously. So for these changes, we'll start with our spawn delay. So we're going to wrap this in an if statement. And so if our spawn delay, if it's greater than 500, then we want to decrease our value. And so once our spawn delay is 500 or less, then we'll stop running our logic here. We'll do the same thing for our enemy speed. So we'll do if our enemy speed is less than 200, then we want to increase it. And so once our enemy speed is 200 or more, we'll stop incrementing it. Awesome. Enemies now spawn from all directions and close in on our planet, adding constant pressure for the player to deal with. Now that enemies are swarming towards the Earth, it's time to give the player a way to fight back. We'll handle collisions between our bullets and our enemies, so when the player shoots, enemies can actually be destroyed. First, we'll set up collision detection using Phaser's built-in arcade physics. We'll check for overlaps between our bullet group and our enemy group and create a handler function that runs whenever a bullet hits our enemy. So to add in our collision check in our game scene, let's come down to our create method. We need to reference our physics system, so we'll do this.physics. We'll use the add method, and now we want to add in an overlap. And so what our overlap method does is it allows us to provide one or more game objects that have an arcade physics body and compare that with the physics body of one or more other game objects. And so what this means is we can check for collisions between all of the bullets in our bullets group and all of the asteroids in our enemy group. How this works is Phaser is going to take our arcade physics body, so this purple box, and check to see if it overlaps with the purple physics body on our bullets that we fire. When they overlap, we can provide a callback function that we want to be invoked so we can run custom code. So inside our method, first we'll want to provide our bullet group. For our second argument, this will be our second object or group we want to check for collisions with. So this will be our enemy group. And now we provide our callback function that we want to be invoked. So for this, we'll make a new method on our class, and we're going to call it handle bullet and enemy collision. For our next argument, this is our process callback, and this is a way for us to provide a callback function that we want to invoke to see if we actually want to have collisions between these two game objects. For our code, we don't need this, so we'll pass in undefined. And then finally, we can pass in our callback context. We want to pass in this for the context of our current class. Oh, for our first argument, this needs to be our bullet group. So now we need to define this new method on our class. So let's copy our method name. We'll come down to the bottom of our file. We'll make our new private method. And now in our method, when this is invoked, we're going to receive two arguments. And so our two arguments, these are going to be our two game objects that are currently overlapping in our game. So for our first argument, this will be our bullet game object, and our second argument will be our enemy game object. For the time being, we'll just do a console log, and let's log out our bullet and our enemy game objects. Alright, so if we save, and we come back to our game, now when one of our asteroids spawns, if we fire our bullet at our asteroid, we'll see once our two physics bodies overlap, we'll see our callback function gets invoked multiple times. So for each step of our game loop, our callback function will be invoked because our physics bodies are overlapping until they pass through each other. So now that our overlap is working, we just need to disable our two game objects, that way we'll be able to reuse them. First, we'll do our bullet, so we'll have our bullet game object. We're going to call disable body, that way we disable our physics body, and now we'll want to make it not active and not visible. So we'll do our bullet, we'll do set active, we'll set this to be false, do set visible, and we'll set our game object to be false. Now we want to do the same thing for our enemy. Let's just update our reference, we'll disable our body, and we'll make our enemy not active and not visible. Let's remove our console log. Alright, so now if we save our changes, if we come back to our game, let's try shooting one of our asteroids, and we'll see right away when our bullet collides with our asteroid, we disable both of our game objects, and then we're able to reuse them in our object pool. Nice. With our collision detection working, and us now disabling our game objects once they collide, let's add some polish. For this, we're going to add a small explosion effect that'll play once our enemy is hit with one of our bullets. So for this, we're going to play a simple animation of having our asteroid explode. And so to do this, we're going to spawn a new game object at the location of where our object was destroyed. Since we will be creating multiple instances of this game object, let's create a group to manage these objects. So if we come up to the top of our file, let's add a new property, and we're going to call this destroyed enemy group. Let's come down to our create method. And so now to create our group, after we create our enemy group game object, let's do this. We'll do our destroyed enemy group property. And we're going to set equal to this.add.group. So for this group of game objects, we don't need to check for collisions between our explosions and anything else in our game. Due to this, we don't need to enable this group for physics. And so now for our group of game objects, let's pass in an empty array since we have no game objects to add at this time. So now we have our new group, let's come down to our handle bullet and enemy collision method. Once we disable our enemy in a bullet, we'll want to spawn one of our explosions. For this, we'll make a new method. So let's do this, and we're going to call this spawn destroyed enemy. And now for this method, we'll want to pass in our enemy's X and Y value so we can spawn our explosion in that location. So we'll reference our enemy game object, so we'll do enemy.x, and then we'll do our enemy.y. And now we need to add this new method, so let's copy our method name. Let's add in our two arguments, so we'll have X and Y. And now we need to create our game object. So we do const explosion will be equal to this, our destroyed enemy group. We'll do our getFirstDead method. We'll pass in true to create our game object. Now we'll pass in our X and Y values. And now for our texture, we want to reference our asset keys and we want to do asteroid explode. Since this is a sprite sheet, we'll do our first frame, so we'll do 0. We want our game object to be visible. So now that we have our game object, we'll want to make sure it's active and visible. So we'll do our explosion, we'll call set active, we'll pass in true, we'll call set visible, we'll pass in true, and now we want to play our animation for having our asteroid explode. So this will be our asset keys, and then our asteroid explode. If we save our changes, let's come back to our game. Once our asteroid spawns, let's try shooting a bullet at it, and we'll see right away we spawn our new game object, and we play our animation for having our asteroid explode. So now that we have our logic working, we just need to clean up our game object once our animation is finished. For this, we'll need to listen for our animation complete event on our game object. So we'll want to reference our explosion game object. We'll use our once method to register a one-time event listener. And now for our event, we want to do our phaser, our animations, our events, and now we want to do our animation complete event. Now for our event listener, we need to provide our callback function. And now in our callback function, we just want to make this game object not active and not visible. So let's copy this block of code here. We'll paste it, but instead we'll set active to be false, and we'll set visible to be false. So now that we have all of our logic in place for our collision detection, and once one of our asteroids is destroyed, we're playing our animation, now we're going to introduce a score mechanic. So every time a player destroys one of our game objects, we're going to increase our score by 1. For the time being, we're going to store this in a variable and then update it later to be in our UI. So to add in our new score mechanic, we'll need to add a new property to our class to keep track of that value. So if we come up to the top of our class, we'll add a new private property. We're going to call this score. So now down in our create method, we'll want to initialize our score value. So we'll do this.score will be equal to 0. And so now we just need to increase our score every time we destroy one of our asteroids. So if we come down to our handle, bullet, and enemy collision methods, after we disable our enemy game object, we'll want to increase our score. So we'll do this.score, and we'll want to increase it by 1. So do plus equals 1. And for the time being, we're just going to log out our player's current score. So do console log, we'll say our score, and now we need to log out our value, so we'll do this.score. So now if we save and come back to our game, as our asteroids spawn, let's try destroying our game objects, and now we should see our new message being logged to our console with our player's current score. That's it for basic collisions. The player can now defend the Earth by shooting down enemies, and they get a point for every successful hit. Right now, the player can shoot down enemies, but what happens if one slips through? We'll add logic to damage the Earth when an enemy reaches it, and eventually trigger a game over. We'll start by detecting when an enemy sprite overlaps with our Earth. Just like with the bullet collision, we'll use Phaser's overlap detection, this time between our enemies and our Earth sprite. For these changes, we need to enable our planet for physics. Currently, our planet game object is just a sprite, and so we need to update our code to do this.physics to reference our physics system, and then we'll do add.sprite. This will create a new arcade sprite game object that will have our physics body that we need. Now if we save and come back to our game, we'll see our new physics body has been added to our planet. So currently our physics body is quite a bit larger than our planet, and we would prefer for this to be a circle shape instead of a square. Our Phaser arcade physics system supports using a circular body. To make that change, we'll come back to our code. First, we need to reference our physics body on our planet, so we'll do this.planet, and then we'll reference our body, and now we want to use the setCircle method. Our setCircle method allows us to specify how big we want our circle physics body to be. For this, we'll do 30 pixels, and now we can provide an offset of where we want to position that in our game. We'll want to do 18 pixels for both our X and Y. Now if we save, we come back to our game, we'll see our planet now has a circular arcade physics body. Now that our planet has a physics body, we can add our overlap check between our planet and our enemy group. We'll come down to the bottom of our create method. Let's copy our line of code where we add in our overlap. We'll paste that. And now for our check, instead of doing our bullet group, we'll want to do our planet, our enemy group, and we'll make a new method for this collision. We'll call this handle planet and enemy collision. Let's copy that method name. We'll come down to the bottom of our class. So now when this method is called by Phaser, our first argument will be our planet game object. Our second argument will be our enemy game object. Now when one of our asteroids collides with our planet, we'll want to disable our physics body and make it not active and not visible. Let's copy our 2 lines of code from our handle bullet and enemy collision method, paste that. And so after we disable our physics body, we'll want our asteroid to explode. Let's copy our line of code where we spawn our game object. And so now if we save, let's come back to our game. Once one of our asteroids reaches our planet, we should now see our asteroid explode. So instead of having our game end immediately, once one of our asteroids touches our planet, we're going to give our planet some health. That way, each time one of our enemies touches our planet, we'll reduce our health, and once we reach 0, then we'll end our game. For this change, we'll want to add a new property to keep track of our health. So if we come to the top of our class, we'll call this property planet health. Now we want to initialize our value. So after we create our planet game object, let's do this. We'll do our planet health. We're going to set it equal to 3. So now let's come down to our handle planet and enemy collision method. Once one of our enemies collides with our planet, we're going to call a new method for updating our planet health. So we'll call this damage planet. Let's add that new method to our class. So we'll do damage planet. So first, we'll add a safeguard to make sure our health is above 0. So if we do if, so we'll do if this, if our planet health is less than or equal to 0, then we just want to return early. Otherwise, we want to decrement our planet health. So we'll do this, our planet health, do minus equals 1. Now let's log out a message with how much health we have left. So we'll do a council log, we'll do planet hit, we'll do HP left, and let's log out our planet health. And then finally, once we reach 0, we'd want to end our game. So we'll do if our planet health, if it's less than or equal to 0, then we'll just do a council log, and we'll say game is over. So now if we save and come back to our game, after some of our asteroids have spawned and they collide with our planet, we should see our log message for where our health is decreasing. So once our planet's health reaches 0, we log our message for our game being over. And so once our game is over, we'd actually want to lock our input and prevent our player from being able to increase their score. To make that change, we'll add a new property to our class. So if we come to the top of our class, we'll call this lock input. We'll come down to the bottom of our create method. After we create our cursor keys, we'll set our new property equal to false. So now down in our damaged planet method, once our game is over, we want to lock our input. So we'll do this.lock input will be equal to true. So now that we've locked our input, we just need to update our update method. So we come up to our update method. Before we check for our input, we'll do if our lock input is true, then we just want to return early from our method. Now if we save and come back to our game, once enough of our enemies hit our planet, our input should now become locked and our player shouldn't be able to move or fire bullets. So now when one of our asteroids collides with our planet, we will also want our player to feel this impact. To add some juice to our game, we're going to add a quick screen shake and then scale our planet up and down when the asteroid hits our planet. It's a small detail, but it makes the hit feel way more dramatic. Phaser has a built-in camera shake effect we can use here, and then we can rely on our phaser tweens to scale up our planet and then scale it back down. For these changes, in our damaged planet method, after we update our planet's health, first, let's add in our shake effect for our camera. We do this to reference our scene. We do cameras to reference our camera's manager. Now we want to do our main camera, and now we're going to do shake. So now for our shake effect, we can specify how long we want this to last and the intensity. We'll have this be 150 milliseconds, so that way it's really quick. And then we're going to do 0.02 for our intensity. Now if we save and come back to our game, once one of our asteroids collides with our planet, we should see our new effect. So now to scale up our planet and then scale it back down, we're going to use a phaser tween. To use our tween, we'll do this, we'll do tweens, and then we'll do add to create a brand new tween. So now for our tween configuration, first we need to provide our target game object we want this tween to be applied to. So we're going to do our planet. Now we need to choose our properties we want to modify. We'll do our scale X property. For this, we're going to do 1.1. Then we'll do our scale Y property. We'll do 0.9. And so this will make it look like we're trying to stretch our planet once it gets hit. Next, we need to provide duration for how long we want this animation to last. So we'll do 100 milliseconds. Let's add our ease property. For this, we'll do our phaser, we'll do our math, our easing, we'll do quadratic. Now we want to do in-out. So now for our tween, we're going to pass in our yo-yo property. We're going to pass this to be true. So what this will do is after our animation is finished and we've scaled our game object to these dimensions, our yo-yo property will allow us to play our animation in reverse and then set our properties back to their initial values of 1. So now if we save, let's come back to our game. Once one of our asteroids hits our planet, we should see our game object stretch a little bit. Finally, for our planet, once our health reaches 0, we want to disable and hide our game object. We'll also spawn in one of our destroyed enemies. That way it looks like our planet explodes after it takes enough damage. So let's remove our console log. After we lock our input, first we'll hide our player ship. So we'll do this.player, we'll do set visible, we'll do false. Now for our planet, we want to call disable body. And now we want to make our planet not active. So we'll do set active, we'll do false, and now we'll do set visible, and let's do false. So now to spawn one of our enemies, let's come up to our handle planet and enemy collision method, and we'll copy our line of code from there. We'll paste it, and now for our positioning, we want to reference our planet, so we'll do this, our planet.x, and now we'll do this and our planet.y. Now if we save, and we come back to our game, once we take 3 points of damage, our Earth should disappear from our screen. Nice. So now that we have all of our logic in place for ending our game, we're going to create a new UI that will show to our players once our game is over. On this UI, we'll show our text game over, and we'll show our player the score that they earned. For this new UI, we're going to create a new phase or scene. So for our project, let's add a new file. We're going to call this game over scene.js. So now if we come over to our game scene, I'm going to copy our top part of our code here. So we have our class. We'll paste that in our game over scene. We'll update our class name. We're going to call this game over scene. We'll get rid of our data keys. Next, let's copy our constructor from our game scene. We'll paste that in. And now for our key, we want to reference our game over scene. So now that we have our new phase or scene, we need to update our game configuration. So we'll come into our main.js file. First, we'll import our new scene. So we'll copy our import statement. We'll paste that in. We're going to do game over scene. And we want to import that in from our game-over-scene.js file. Now, if we come down to the bottom of our code, let's copy one of our lines of code where we add our phase or scenes. We'll do our game over scene for our key. And now we want to do our game over scene class. So now to make it a little bit easier to test, let's open up our preload scene. And at the bottom of our file, instead of starting our game scene, let's start our game over scene. Now if we save and we come back to our game, now we should just see our black canvas element. Now in our game over scene class, let's add our create method. And first, we'll want to create our background game objects that we're using in our game scene. So if we go into our game scene, let's copy our block of code here where we create our background game objects. We'll paste that in. If we save and we come back to our game, we should now see our game background. So now in our scene, we're going to add some text game objects. Our first one will show the text game over, and our second one will tell our player to click to play our game again. To add our text game objects, we're going to do this.add.text. And now for our position, we want it to be in the center of our screen. So we'll do this.scale.width. We'll divide it by 2. And we'll do 100 for our Y. For our text, we're going to do game over. And now for our text styling, let's do our font size. And we want to do 32 pixels. Now if we save and come back to our game, we'll see our new text game object is visible. And now we just need to update our origin so our text will be centered. So on our game object, let's call set origin. And we'll do 0.5. Let's save. Much better. Let's copy that block of code. For our other text game object, for our text, let's do click to play again. Now for our font size, we'll do 22 pixels. Now for our position, let's do 350 for our Y. We save and come back to our game, we should see our new text. Now finally, we want to add a text game object that's going to show our player their score. So let's copy our block of code, we'll paste it one more time, and now for our text, we're going to do score, and now we're going to add a new property to our class. We're going to do this.score. Finally, for our font size, let's do 24 pixels, and now we need to add this property to our class. For this, let's add our init method. Now in our init method, we'll do this.score. We're going to set it equal to 0. Let's add that property to our class. So we'll do score. So now if we save and come back to our game, score is undefined. In our create method, we need to reference this, and then our private property. Much better. So now in our game over scene, we just need to add in our logic, so once our player clicks, they'll be able to start our game scene. At the bottom of our create method, we'll do this, our input to reference our input manager, and now we'll use our once method, and now we want to listen for our pointer down event. So we're going to do phaser, let's do our input, our events, and now we want to do our pointer down event. For our second argument, we'll do our callback, and now in our callback, we want to start our game scene. So we'll do this, we'll do our scene to reference our scenes manager, now we'll do our start method, and let's do our scene keys, and we'll do our game scene. Now if we save and come back to our game, on our game over screen, if we click, we'll now transition to our game scene. So now that we have our new game over scene, we now need to connect it to our game scene. So if we come into our game scene, let's come down to our method where our plant takes damage. Once our health has reached 0, now we want to start our game over scene. So we'll do this, we'll do our scene, we'll do start, and now for our scene key, let's do our scene keys object, and let's do our game over scene. So let's go ahead and save. If we come back over to our preload scene, let's update our code to take us back to our game scene. Now if we come back to our game, now when our game starts, we're in our game scene. And now if we let our planet take some damage, we should transition to our game over scene. So now the last thing we need to do for our game over scene is once our game ends, when we call our game over scene, we need to pass our player's score value so we can display it in our scene. And so to do this, when we call this.scene.start, one of the things we can do is pass a secondary argument, which is an optional object. This object, for any data we pass, this will be provided to our scene when it started. So on this object, we can add a property called score, and now we can reference our score property on our class. So now when we pass this data object on our game over scene in our init method, Phaser is going to pass that as an argument to our method. So now instead of setting our score to 0, we can reference our data object and then our score property on that object. Now if we save and come back to our game, if we destroy a couple of our asteroids and then let our asteroids collide with our planet, if we transition to our game over scene, we should see our new score value visible in our scene. At this point, our core loop of our game is complete. Our enemies are on a collision course with our planet, our player can defend our planet, and the Earth can now take damage. We've got the gameplay working. Now let's make it feel more complete and fun to play by adding some visual polish and user interface elements. First, let's display our player's current score on our screen. We already increased the score each time an enemy is destroyed, so now we need to create a simple text game object in the top left-hand corner and update our text as our score changes. For this change, we'll go into our game scene. First, we'll want to add a property to keep track of our text game object. That way we can modify our text when our score updates. So for this new property, we'll call it score text. Now if we come down to our create method, so now after we initialize our score to 0, let's create our text game object. For our text game object, let's do const. We'll do our score text prefix. For this, we're going to set equal to this.add.text. And now for our position, we're going to do 10 for our x, 10 for our y. And now for our text, we're going to do score. We'll do score colon and then space. Now for our text styling, let's do our font size. And let's do 16 pixels. Finally, for our game object, we want our text to be displayed on top of everything else in our game, so we're going to use the set depth property to make sure it's displayed above everything else. So we'll set our text game object to be 2. So now if we save and come over to our game, we should see our new text game object added in our top left-hand corner. So now we have our score prefix. Now we need to create a game object for our actual score. So for this, we'll use our score text property. We'll set it equal to, I'm going to copy this block of code. We'll paste it. Now for our x value, we're going to want this to be based on our text game object that we added for our prefix. So we'll reference our score text prefix. We'll grab our x value, and now we want to add in our display width. That way our score value isn't on top of that text game object. So if we do our score text prefix, then we'll do our display width. So now for our y value, let's do our score text prefix game object, and we'll grab our y value. Now for our text, we'll set this to be 0. So now we'll keep the same font styling and our depth. We save and come back to our game, we should see our score now displays 0. So now that we have our text game object, we just need to update it when our score increases. So if we come down to our handle bullet and enemy collision method, let's remove our console log before we update our score. Now we can do this. We'll reference our score text game object. Now we want to call set text, and now we can pass in our score value as a string. So do this.score, now we'll do toString, and then we'll pass in 10. Now if we save and come back to our game, let's try destroying one of our asteroids, and we'll see our score starts updating as we destroy our enemies. Nice. Next, we'll add a visual indicator for the Earth's health. You can do this as a row of heart icons, a health bar, or even a number. For now, we'll keep it simple. We'll display 3 heart images below our planet and remove one each time our planet takes damage. For the hearts we'll display for our planet, we'll need to create a sprite game object. That way we can use our animation that's tied to our heart here. To make it a little bit easier to work with our heart game objects, we're going to create a phaser container game object. A container, as the name implies, is a game object that can contain other types of game objects. And so what's really nice about our container game objects is when we place our game objects inside our container, their positions are calculated based on where our container is at in our game. This makes it really easy to position groups of GameObject together in our scene. So to keep track of our container GameObject, let's add a new property to our class. We're going to call this Planet Health Container. And so now to create our GameObject, let's come down to our create method. After we set our planet's health, we'll do this. We're going to do our Planet Health Container, set equal to this.add.container. And now for our GameObject, we want to position this just below our planet. So for our X value, we'll do this, our scale, our width, we'll divide it by 2. And now we're going to grab our planet's position, and we'll grab our Y value, and we'll add 50 to it. And then for our third argument, we can pass an array of game objects that we want to add inside our container. And so for these objects, these will be our heart game objects we want to create. So let's do this.add.sprite. So now for our X and Y position, we'll do 0, 0. And now for our asset, we want to do our asset keys. We want to do our heart. Since this is a sprite sheet, we'll pass 0 for our first frame. And now we want to call our play method. We want to do our asset keys and then our heart. So now if we save, we come back over to our game. We should now see our new heart game object position below our planet. So now we have our first heart game object. We just need to add 2 more to represent our full health. For that, I'm going to copy this line of code. We'll paste it twice. So now for our first heart game object, we want this to be left of our current position. We'll do -18 for our X. And then for our third game object, we want this to be on the right-hand side. So we'll do 18. And now if we save and we come back to our game, we now have our 3 heart game objects. Finally, for our heart game objects, as our planet takes damage, we'll want to remove that game object from our scene. To make this change, we'll want to come down to our logic where we update our planet's health. Let's remove our console log, and now we'll want to destroy one of our game objects. So we'll need to reference our Planet Health container, and now we want to use the getAt method. And so what the getAt method allows us to do is we can grab one of our child game objects from our container based on its index. And so when we create our 3 heart game objects and add them to our container, our first heart will have an index of 0, our next one will have an index of 1, and then our last one will have an index of 2. And so based on that index, we can pass that value here to get that game object. And so for this value, we're going to use our Planet Health property on our class. How this will work is when our game starts, our health will be set to 3. Once we take damage, we're going to decrement this to be 2. And when we do that, when we go to grab our game object, that's going to allow us to grab our third game object we added to our container. Once we take our next point of damage, it'll drop down to 1, which will allow us to grab our middle game object. And when we take our final point of damage, it's going to drop to 0, which will allow us to grab our first game object. So once we have our game object, now we can call the destroy method to remove it from our game. We come back to our game. If we let one of our asteroids collide with our planet, we should see our heart game object disappear. And now each time we take damage, one of our heart game objects is removed from our game. For our next bit of polish, we're going to work on adding some transitions when we transition between our phaser scenes. Currently, when we go from our game scene to our game over scene, the transition is very abrupt, where we just stop our existing scene and then immediately show our game over scene. For our transition, we'll have our scene fade to black, and then we'll have a nice fade in effect on the scene that we're starting. To do this, we can use some of the built-in methods on our phaser camera. So in our damage planet method, instead of transitioning right to our game over scene, we'll want to do our fade out effect. To create this effect, we can do this. We'll do cameras to reference our cameras manager. We'll do main to reference our main camera. And now we'll do our fade out method. Our fade out method allows us to specify how long we want this camera effect to last for and what color we want to fade to. By default, all of these arguments are optional. And so for our fade effect, it would be 1 second or 1000 milliseconds. For our game, this is a little bit long, so we're going to set this value to be 500. Now for our color, we can specify our red, green, and blue values, and that will determine the color that we'll fade to. By default, if we emit those, we'll fade to the color black. Now that we're triggering our fade out effect, we need to wait until this is completed before we start our next scene. We can listen for our built-in events in Phaser for when our fade out is completed. To listen for this event, we're going to do this.cameras.main, and now we're going to use the once method. The once method allows us to register a one-time event listener or a given event by its name. For the event we want to listen for, this is going to be our phaser, our cameras, our scene 2D, then our events, and now we want to do our fade out complete event. And so now when this event is fired, now we can provide the callback that we want to invoke. Now in the callback function here, this is where we want to start our game over scene. Now if we save and come back to our game, now if we have our planet take enough damage, we should now see our nice fade out effect. So now, once we start our game over scene, our scene immediately flashes on our screen. For us to complete our transition, we're going to do a fade in effect when our game over scene starts. To do this, we'll come into our game over class, and our create method at the bottom. Let's do this, we'll do our cameras, we'll do our main camera, and now we want to do our fade in effect. For our fade in effect, this is very similar to fade out, where we can specify our duration, and then what color we want to fade in from. We'll stick with our default color of black. Now if we save and come back to our game, let's have our planet take some damage. Once we take 3 points of damage, we'll fade out to our game over scene, and then we'll fade in once our scene starts. So now we'll want to do the same thing from our game over scene to our game scene. So if we come back to our code, let's jump over to our game scene. Let's come down to the bottom. Let's copy our code for our camera transition. We'll come to our logic where we start our game scene. Let's paste in that code. Now let's take our line of code where we start our game scene, and we're going to replace that, and then we'll paste it down here in our event handler for our fade out complete event. Next, let's copy our line of code for our fade in. We'll come to our game scene. Let's go to the bottom of our create method. Let's paste in that line of code. We'll save. Now when our game starts, we have a nice fade in effect. And now if we take damage, we should fade out and go to our game over scene. And now when we click, we have our fade out effect, and then we fade in to our game scene. Nice. For our next round of polish, we're going to add some sound effects and background music to our game. So in our assets folder, under audio, we have some background music and sound effects we want to add to our game. Our Space Asteroids file here will be our background music, and then we have some sound effects that will play once one of our asteroids is destroyed and when we fire our weapon in our game. For our background music, we'll want this to play throughout our whole game. A good spot to do this will be in our preload scene in our create method after we've loaded in all of our assets. So in Phaser, our sound manager, this is one of our global services in our game. What this means is our sound manager, this is shared by all of our scenes in our game. Due to this, we can play our background music in one scene, and once we transition to our next scene, our background music will continue to play. And so if we want to play our background music, we can do this to reference our phaser scene. We'll do sound to reference our sound manager. And now we want to do the play method to play our audio file. So now in our play method, our first argument is going to be the key of the audio file that we loaded in Phaser. For this, we'll want to reference our asset keys. So if we come up to our import, let's add in our asset keys. Now back down in our play method, we'll do asset keys. And now we want to reference our background music. For our second argument, this is an optional object that allows us to provide settings that we want to apply to the sound that we're playing. And so for our settings, this can include things like our loop property. And so if we want our music to loop in our game, so for our background music, we want this to be true. We can also modify the volume that our audio file will play at. And so for this property, this should be a value between 0 and 1, where 0 would be our sound won't be audible at all, and 1 would be the default volume of that audio file. So now if we save and come back to our game, once our game starts, we should now hear our background music playing. So even though we transition from our preload scene to our game scene, we can still hear our background music. Once we transition to our game over scene, we should still hear our background music playing. Now that we have our background music working for our game, let's add in the rest of our sound effects. So let's copy our block of code where we play our background music. We'll come to our game scene. First, we'll add in our sound effect for when we fire one of our bullets. So if we come down to our fire bullet method, before we do our console log, we'll paste in our code. And now for our sound effect, we want to do our asset keys. Now we'll do our FX shot. Now for our sound effect, we don't want this to loop. We only want to play it one time. So let's remove our loop property. By default, that property is set to false. Now for our volume, we don't want this to be as loud as our background music, so we're going to do 0.1. So let's copy that block of code. Next, we'll add in our sound effect for one of our asteroids is destroyed. So if we come down to our method where we spawn our destroyed enemy, at the bottom of our method, we'll paste in our code. Now for our sound effect, we want to do our FX, and we want to do our explosion. Now for the sound effect, we'll do 0.5. Finally, we want to play a sound effect once our planet takes damage. So if we come down to our damage planet method, after we do our tween animation, we'll paste in our code. Now for our sound effect, we want to do our FX and then our hit. For our volume, let's do 0.4. Now if we save, we can go back to our game test. So now when we fire our bullets and we destroy our asteroids, and when one of our asteroids collides with our planet, we should hear our various sound effects. Now for our final bit of polish. For our game, we're going to create a new title screen that will display when our player first launches our game. On our title screen, we'll display the name of our game, as well as the text "click to play" so our player can start our game. To add our new screen, we'll need to create a new phaser scene. So under our scenes folder, let's make a new file. We're going to call this title scene.js. Let's go into our game over scene class. Let's copy all of our code. We'll paste that into our title scene. Let's update our class name. We'll do title scene. Let's remove our score property. Now our constructor, let's do our scene keys. And now we want to do our title scene. We'll remove our init method. So now our create method, first we'll create our background. So now for our text game objects, instead of displaying game over, we'll display planet defense. We'll keep our same X and Y value and the same styling for our game object. Next, let's get rid of our game object tied to our player score. And now for our text, let's do click to play. We'll keep the same position and same styling. And now we'll want our player to click on our screen to transition to our game scene. Finally, for our title screen, let's add our planet that our player will need to defend. So let's do this.add.sprite. Now for our X position, we want this to be in the center of our screen. We'll do this.scale.width. We'll divide it by 2. For Y, let's do this.scale.height. We'll divide it by 2. For asset keys, let's do our planet. We'll do 0 for our frame. Now let's play our animation to have our planet spin. So we'll do our asset keys, and let's do our planet. So now that we have our new scene, we need to update our game configuration. So if we go into main.js, first we'll want to import our scene. I'm going to copy this line of code, we'll paste it. Let's do title scene, and now we'll import that from our scenes, and then title-scene.js. At the bottom of our class, let's copy one of our lines of code for adding our scene. We'll do our scene keys. Let's do our title scene. And now we'll do our title scene class. Finally, let's go into our preload scene class. Instead of transitioning to our game scene, we want to transition to our title scene. So now if we save, let's come back to our game. When our scene starts, we should have our nice fade in effect, and we should see our new phaser scene. So now if we click to play our game, our scene should fade out, and we transition to our game scene. Nice. That's it. We now have a fully working game with core mechanics, enemies, difficulty scaling, score tracking, and UI polish. And that brings us to the end of our Planet Defense game course. Let's take a moment to recap everything we've built together. We started with a blank Phaser 4 project, and gradually added features step by step. First, we added our planet sprite and created a player's ship that orbits around it using polar coordinates. Then we added input so our players could rotate our ship around our planet and shoot our bullets outward. After that, we brought the action to life by spawning enemies that move toward the Earth from all directions. We handled collisions, added a score system, and built the logic for enemy destruction. Once the core gameplay was solid, we implemented Earth damage and game over mechanics, so if too many enemies get through, the Earth takes damage and the game ends. Finally, we polished everything up with a user interface, score display, health indicators, screen shake effects, background music, and multiple scenes like a title screen and game over screen. If you made it this far, congratulations! You now have a complete, fun, arcade defense game built entirely with Phaser 4. You can take what you learned here and extend it even further. You could try adding in power-ups, different types of enemies, mobile support, high scores with local storage, or even additional scenes for your game, such as instructions, options, or a credit scene. Thanks so much for following along with the course. If you enjoyed this, please consider giving the video a like, leaving a comment to let me know what you built, and subscribing for more game dev content. See you in the next video, and happy coding!